I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 40. We are still in our houseplants unit, and it's all about Cheryl's houseplants. So, Cheryl, what question do you have about your houseplants this week?
Well, Ryan, I really thought we'd covered everything there was to talk about with my houseplants.
Did you know? Absolutely everything.
We covered all of the science that could be discussed behind my houseplants.
Yeah.
And then this weekend, my husband was doing one of his favorite hobbies, which was working on his fish tank. He has a fish tank, and then my stepson has a fish tank. So there's two fish tanks in our home.
Okay.
And he has like logs for fish to like hide behind and rocks, and like he like works really hard on like the ecosystem in it and everything. And one thing he was doing was trimming the plants, the live plants in our fish tank. And I was like, oh, we have house plants I didn't even think about that are underwater.
Oh, okay.
And so I was thinking about that and everything that you've taught me about houseplants and how they need sunlight and water and oxygen, but not too much water and not too much or too little sun, all these different things we had learned. And I was thinking, how are these plants in this tank even surviving underwater? What are they doing there? What's their deal?
What's their deal?
Yeah.
So that's this week's question. What's their deal?
Yes. Yeah. What's the deal with aquatic plants?
What's the deal with aquatic plants? All right. Well, let's just start with what you already know as a pre-assessment.
Okay.
Why do you think that it's weird for plants to be living in the water?
Because we talked all about overwatering.
Okay.
And how it drowns the plant.
What drowns the plant?
Overwatering or underwatering.
Okay.
Well, underwatering doesn't drown the plant, but like it prevents them getting oxygen, essentially.
Okay.
So like if I took one of my house plants and just like threw it in this fish tank, I think it would die.
Okay.
Because it'd be a lot of overwatering. So then these other plants are just like fine with that, or I mean, actually thrive on being like immersed in water all the time.
Okay.
So that's just feels inconsistent to me with what I know about roots now.
Okay. Sure.
And then I'm assuming they still get sunlight because obviously like the light can shine through the water. So they're still getting light, and we all know that that's very important. I'm also assuming if there's plants that live further down, that they just need less light than plants that live near the surface, would be my guess. But they don't have any soil. And I keep referring to these little things as roots on them. And then my husband tells me they're actually ribosome, something. It's not really roots, but it's like roots. It like does the same thing as roots, but they're not in soil. Some of these aquatic plants could just float in the water and live their life and be happy. So they don't even need any soil. And then it sounds like maybe some of them just use their roots just to like attach to something and stay in place. But it means that they're not soaking up any nutrients that would be in soil because there isn't any soil.
Okay.
So then they must be getting nutrients some other way. But they're just in salt water. Is that really all the nutrients they need?
Okay. Do you remember? We only did this once and it was only part of a lesson. When we talk about nutrients, do you remember what those are, what that actually means?
Well, there were a couple main ones. There were like three main ones. I feel like one of them was nitrogen.
Okay.
And one was maybe iron or iron was when we listed and then said it was a lesser one. I don't remember.
Okay.
There was one we listed and then we were like, that's not one of the main three, but it is still a
Yep.
thing.
Yep. And that was iron. Yep.
Okay.
Yep.
And then there were two others
Uh-huh.
that one of them, like they did different things. Like one of them made them successfully move the water around the
Okay.
whole plant.
Mm-hmm.
And they did like different things. One of them made it stronger, maybe.
Okay.
I used the word stronger, and then you told me what it actually does, and I was like, "Yeah, that's stronger." I feel like that happened. We'll go back and listen.
Sure.
Yeah.
Okay. And so you think that those are not accessible to plants that are underwater?
Well, I mean, they have H and O underwater. They have hydrogen and oxygen because
Uh-huh.
of water.
Okay.
So I'm assuming they get it like a fish gets it. No, they don't have gills. They probably get it like any other plant gets it through the roots, but some of them barely have any roots. So are they just absorbing it through their leaves, or do they have a part of their little bodies that they absorb the water through? And I'm assuming that's what gives them hydrogen and oxygen. But like, are they getting it through things like fish poop? Oh, I mean, now that I think about it, my husband did say that like the plants are good for the fish. Like it makes the tank healthier for the fish. And then also, I think the fish are good for the plants, maybe because of their poop. It might be related
Okay.
because animal poop is good for plants. So then maybe they just get it through like other things happening in the tank. But then if they weren't in a fish tank, if they were just in a container of water and only plants, would they survive at all? Or they
Hmm.
just like be less healthy than if they're with like living things? We also have snails and shrimp in our I'm just gonna show you a picture. Here we go.
Okay.
This is a little thing. If you're not watching our YouTube, hop on over there
Yep. We have pictures a
because
lot during this unit, and Cheryl
we
has all sorts of pictures.
of my house plants. So here's our tank.
Oh, very nice.
Yeah. And you can see there's like two really pretty rocks, three
Mm-hmm.
rocks, and then these big pieces of wood,
Mm-hmm.
which the plucky likes a lot. Everybody likes the wood. The snails lay their little eggs in the wood that won't hatch. Um, that's a mystery snail. It's one of my favorites. I named that one Ariel because she likes to be near the surface a lot.
When you say
Um,
mystery snail, is
it's
that
a
the
type of a
species of
snail.
snail? Okay.
Yes, yeah,
Okay.
that's a species. But you can see we have this grass here,
Mm-hmm.
and then we have this plant here.
Mm-hmm.
And then we just bought another plant that's in like this section called
Okay.
wisteria. And then we have
Okay.
this one here. Now, if you wanted to know their names, we would need to get Daryl in here because I don't remember most of them. And then we have this one in the front, and then we have this one, which right before we recorded, Daryl walked in and held up like 2 feet of this. This
Yeah.
is hornwort, and it's grown like across over here and stuff. So it's like
Yeah.
taken off. So we have 1, 2, 3, 4, 5, 6. I think we have about 7 different plants.
Types of
And you can
plants or
see
just different individual organisms?
types
Okay.
of plants and
Okay.
many more than that as far as organisms go. This guy here, you can see the little like root, not root, that goes all
Oh.
underneath
So
this
the plant
log.
itself almost looks like individual, each leaf almost looks like a piece of lettuce, but it doesn't look like a lettuce plant. And it looks like it's coming out of the log. And
Yeah.
then it must be going around behind the part of the log that we can't see. And these little tendrils are kind
Yeah.
of coming around and wrapping. It looks like they're actually like almost wrapping around
Yeah.
another part of the log. Oh, you got all sorts of pictures.
I have all sorts of pictures. Oh, there you can see the tendrils even more. This is a picture I took of 4
Oh,
snails,
uh-huh.
but really you can also see that plant quite well.
Yeah, and I can also see that each of the tendrils has little tiny, even smaller tendrils coming out almost perpendicular to the main path, I guess, of the tendril, main arm,
Yeah,
main
like
tend of the tendril.
like a tree with branches.
Kind of. Yeah.
Yeah. Where else are my plants? Oh, there's more of those tendrils. Apparently, I like taking pictures of that part of the tank
Apparently.
because cute little fish hide down there. Oh, this one too. We have this. You see these big, like leafy
Mm-hmm.
guys? That's a fun one.
Really flat leaves.
Yeah.
Because some of the other ones look like almost like little
Bushy. Yeah.
little mini bushy tree like things.
Here's a shrimp. This is a ghost shrimp,
Oh,
but you can see all these plants he's near.
yeah. Yep.
And he looks creepy and funny.
Well,
Yeah.
you just think he's creepy because he's clear and you can see inside him.
Well, also look at his eyes staring right at you.
I mean, that's what
funny.
most eyes do. But sure, it's creepy.
I think it's because they're like off of his head.
Most eyes are connected to your head.
No, off of his head. Like,
Oh,
these
like on the little stalks that are poking.
yeah, and then the eyeballs like right on the end of it. It's so
Okay,
funny.
I see. Okay.
We have a lot of little funny animals in there.
Okay.
That's great. Anyway, there's my show and tell. For the
Thank
day.
you. Thank you. All right. So is there anything else you feel like you know about aquatic plants and either what makes them able to live or what makes it not make sense for why they can live underwater?
I feel like I said everything I had to say.
Okay.
Yeah.
we will use that to move forward
Okay.
then. Well, there's a lot going on here, Cheryl. So there's a lot for us to talk about. Are you ready?
Yes.
Okay. First of all, you remembered a lot of really good things from some previous lessons.
Oh my gosh, yay!
Yay! It's almost like you're
exciting.
learning.
Oh my gosh, so close to learning.
So close. Overwatering plants does tend to drown them because it prevents them from being able to absorb oxygen in the roots.
Yep.
Right? You talked about that. That is true.
Okay.
Which means your question makes a lot of sense. Well, then how does it work for plants when they're underwater the whole time?
Yeah.
Yeah. We'll get there. The second thing you talked about. Do you like, isn't that fun when a teacher says, yeah, we'll get there.
Such a cliffhanger.
Yeah. The second thing you mentioned was that they still have access to sunlight, but the farther down they are, the less sunlight there is. And that is completely true, which is why you tend not to see aquatic plants very deep. If you think about, whenever you see the deep ocean things, when they go down to the bottom of the ocean, like out in the middle of the ocean, and it's just barren. There's almost nothing there.
Oh, yeah. Yeah.
Including pretty much no plants.
Oh, that's a good point.
Yeah. So you're right. And that's why in relatively shallow water, when the light can still filter down, that's where you can still see plants. Thinking the ocean. Also think of things like lakes or even rivers. There can be aquatic plants, and not all aquatic plants are submerged entirely either. If you think about it, think of like lilies and lily pads. Right?
Yeah.
They have parts that actually are up at the top of the water, and they have nice big flat leaves. That's what the lily pad is, to be able to absorb that sunlight more effectively.
Yeah, totally.
So those are things. And then you talked about there being no soil. And that depends. Some aquatic plants, in fact, don't really need soil. And then their roots, just like you mentioned, act more as an anchor.
Yeah.
To hold them to whatever, we call it a substrate, but whatever the thing is that they're trying to attach to.
Okay.
And you also mentioned that part of that you thought was because maybe they can absorb things from the water through their leaves. And you were right.
Really?
Yes.
Cool.
Most leaves, terrestrial, like on land, have sort of a coating. It's called the cuticle. That's kind of on the outside that helps prevent water from just leaving the plant. Because if it's in a really hot environment, oftentimes the water can just kind of evaporate out of the leaves. Think of like if you have a succulent, they're usually very waxy on the outside.
Yeah.
It's kind of like an extra thick cuticle to help prevent the water from just evaporating out of the leaves. Well, if you live underwater all the time, you don't need to worry about that.
Oh, that's a good point.
That means that those plants, aquatic plants, their leaves usually are a lot thinner and don't have that outer coating, so they can more easily absorb things through them.
Oh, cool.
I mean, it works well for them.
Yeah.
Yep. But there are some aquatic plants that do actually need soil for the reason that you mentioned. They're absorbing nutrients through the soil. And you remembered nitrogen and iron, which
Yeah.
are two of them. The other two, which when you hear them, you're like, oh, yeah, I remember phosphorus.
Oh, yeah, I remember.
And potassium.
Got it. Okay. Yeah.
And then there's a whole bunch of others that they need smaller amounts of and things, right? And I mean, we kind of moved over oxygen. We kind of skipped over that one.
Yeah.
How do you think aquatic plants get oxygen?
I already told you earlier.
Tell me again.
From the O and H2O.
Oh, I see. Yes. That's actually not where they get the oxygen
What?
from.
Where do they get it from?
There is oxygen dissolved in the water itself, the same way that fish do with their gills.
But isn't that what the O is in H2O?
No, H2O, that's a molecule. That's, oh, look, I even have one right here.
Oh my gosh, of course you do.
Of course I do. You remember this little guy?
Yeah,
remember?
little Mickey Mouse popcorn
Little Mickey
ball.
Mouse, right?
Yeah.
It's all connected.
Okay.
Okay. Whereas, and this is not going to work as well because I don't have the things that join them together. Oxygen is actually O2, which is two oxygens that are connected to each other.
Okay.
H2O is two hydrogens connected to one oxygen. In
okay.
order for to get the usable oxygen from a water molecule, you have to break the bonds between the hydrogens and the oxygens, and you have to use energy to do that. They don't just I can't just take whatever I want from it. Think of it's not exactly the same thing, but think about when you eat food, you have to digest the food, break it down into smaller pieces for your body to absorb it. You can't just take whatever, pick a food. Spaghetti, rub it on your arms, and then it just absorbs into your skin. Look,
I'm so
I got all the
happy
spaghetti.
I said spaghetti.
Right? You can't.
Yeah.
The reason you have to digest is to break it down into smaller parts.
Okay.
It's not exactly the same thing, but it's similar where you can't just take the water. Water is its own thing, and there is oxygen in it. But if you need the oxygen, you actually will use O2. That's just oxygen.
Oh, so that's why. So we have something in both of our tanks that produces little bubbles that go up through the water. And
Yes.
Daryl was telling me it's good for the fish and everybody because he's putting more air.
Exactly.
In
it
the
is.
water.
But yes. And the biggest part is the oxygen. Yeah. It's what we say is it's oxygenating the water.
Oh, yeah.
It's the same reason why if you have a pond or something that is really stagnant.
Yeah.
There's not a lot of movement. It doesn't have a river or a stream running into it or out of it. It's just kind of stagnant. Typically, there's not a lot of stuff that's living there. And if it is, it tends to smell really bad because things are rotting and coming apart because there isn't that oxygen circulating through to allow a lot of things to actually live other than really small bacteria and archaea and things.
I totally thought that gills were just pulling the oxygen out of the water
The
molecules.
H2O.
Yeah.
No, they're pulling the actual O2 molecules out of the water. Think about a carbonated beverage.
Yeah.
Right? That's carbon dioxide, CO2, that's dissolved into the liquid.
Oh.
Right?
Okay. Yeah.
And some of it, if you, take a can of pop or LaCroix or whatever, and you, right? And that's letting out some of that. And there's bubbles that's coming out of the solution. But even before, where is it coming from? It's already in the liquid. And the oxygen's there too. I know we're totally getting off track of aquatic plants, but this is how it works.
No, it's fine. It's just funny because that's a future episode you and I have talked about doing too.
And it's connected to aquatic plants.
Interesting. Okay. So that's how they get their oxygen.
Yeah, the oxygen is dissolved in the water, and then they absorb that through their leaves. And then the nutrients, the other nutrients, the nitrogen, the phosphorus, and the potassium, some aquatic plants will absorb that through their roots, and others will absorb it just through what's around them, which is a little bit more challenging. But again, it depends on the plant and the environment that they're in. You also referenced fish poop.
Yeah.
And that we use manure as a fertilizer. It's because there tends to be, especially the phosphorus and the potassium, in the waste products that's left over. And so, yes, fish poop in the water, eventually it'll break down into smaller bits, and some of those aquatic plants can absorb those.
So that's part of why they help keep the tank cleaner.
Yes, that's why
It's
they
because
help.
they're actually
Yep.
using the poop for
Yes.
good things, and it's
Yep.
less of it would be just sitting there.
They're absorbing
then.
parts of it, not all of it, but parts of
Yeah.
it. Also, your aquatic plants are producing oxygen through
Yeah.
photosynthesis. And so they're also oxygenating the water in addition to the bubbles.
Cool.
It's almost like you're creating a little mini ecosystem.
Yeah, I know. It's so cool.
And I think those were all of the key parts of what you talked about. Do you feel like there's any part of your question that we haven't quite addressed yet?
No. That makes sense.
Yeah?
Yeah.
Okay. I guess that means we are ready for a quiz.
Oh. I don't have any excuses today, so I guess here we are.
I guess here
taking
we
a
are.
Quiz.
Yay, I know you're so excited. First question. Why don't we see plants on the deep ocean floor?
Because there's not enough sunlight down there. There's not really any sunlight.
There's not really
Down
any.
there.
Yep. Which
Yeah.
is definitely not enough.
Yes.
Bonus question. We didn't directly say this. Why, if they don't have sunlight, what is it that they can't do?
Photosynthesis.
Hey, bonus points for Cheryl. Next question. What are 2 ways that aquatic plants can use their roots?
As an anchor
Mhm.
or to absorb nutrients.
Wonderful. And that leads us to question number 3. What are the 3 primary nutrients that plants need?
Nitrogen, phosphorus, potassium.
Hey, way to go.
Yay. It might stick. Now I've said it twice. So
You have that, and repetition does help if you're
Oh.
trying to remember something.
100%.
Yep. Okay. Next question. Not all aquatic plants need soil. For those that don't, how do they get their nutrients?
They absorb it through their leaves.
There you go. Nice. Out of the water through their leaves. And finally, where do aquatic plants get their oxygen? And as a side answer, where do they not get it from?
Well, they don't get it from the air, like being out in the air,
True.
because they're not there. They also don't get it from the O and H2O because they would have to do some complicated science that they don't know
Fair.
To-
Okay.
to break down molecules,
Mhm.
but they get it from the oxygen that is dissolved in the water.
Exactly. Very nice. Look at that. Look at all those wonderful things that you learned this week, Cheryl.
Yay!
Do you
That's
feel
exciting.
accomplished?
I do. I feel like I understand my other houseplants better now.
Your surprise houseplants that you didn't even remember you had.
Yeah.
Wonderful. Well, why don't you go ahead and pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
Ah! The bell doesn't dismiss you. I dismiss you.